Hello, welcome back. The title of this lesson is called Calculating Angles. This is part 1. So in this lesson, we'll have a series of geometric diagrams, and we'll give you some information in the drawing, and we'll have to calculate the numeric value of an angle. Now, I'll tell you right now that all of these problems really only require addition and subtraction to solve them. So they'll be very easy for you just to subtract and add, no problem. But we're going to write down the solutions kind of as an equation and use an equation to solve it, even though you could just skip ahead to just straight subtraction, because I want you to practice your equation skills. So when you look at these, you might say, oh, I could just do this. That's fine, but I also want you to get practice solving equations. So here's our first question. We have this diagram here. We have two kind of lines that go on forever and ever in both directions. So we have this angle here of 120, and we're trying to find the angle x. Now remember, we learned about vertical angles. Anytime you have an x or a plus, the opposite angles there on either side are equal. So these angles are actually equal to each other. So without doing any math at all, you know that the angle x has to be 120 degrees. There's nothing to add or subtract because you know they're equal. And just as an aside, these angles here are also the same. You can see that they look to be about the same as well. So opposite angles in a situation like this, we call them vertical. And so we know the answer is 120 without any further work. All right, let's take a look at problem number 2. We have this situation. It's very similar. In fact, it's the same drawing, except now we have angle y over here, and we're trying to figure out what is the angle y. Now, you need to start getting in the habit of seeing, when you see these straight lines that are broken up by another segment or a line, these are what we call supplementary to each other. They add up to 180 degrees. And you know this because any angle on a straight line from one side to the other has to be 180 degrees. So this plus this has to be 180. So in equation form, what you would say is 120 plus whatever y is in degrees has to equal 180 degrees. This is what it means to be supplementary. Now, in order to solve this, we'll just kind of spread it out a little bit and ask ourselves, how do we get y by itself? Well, we have a positive 120, so we'll subtract 120 from the left and subtract 120 from the right. And on the left, of course, the 120 minus 120 is 0, so all we have left is y, and 180 minus 20 is 60 degrees. So just put 60, and the unit is degrees. So 60 degrees. So this is what I was saying a minute ago. You can just solve these with subtraction. You know that this has to be a large angle of 180. Subtract this away, minus the 120, has to be what you have left. So you can do that, but I am writing them in terms of equations and subtracting from both sides because I want you to get practice with this kind of procedure with equations. All right, so 60 degrees, that was the answer there. Let's take a look at problem number 3. What is the measure of angle K here? Now, at first, you're not really sure what to do because K is way off by itself and you don't really know anything about what's going on over here, but you need to learn how to read geometric diagrams. When you see like an angle marking here, and then there's like another angle marking there, and if it's a true geometric diagram, it's like, congruency marks. When you want to tell me that the length of the sides are the same, you put a little mark on the sides. Well, for angles, if you put a little mark here or a little angle arc, and it matches the angle mark here, then you can assume those to be equal, if it's a proper geometric drawing, right, in this case. So what you know is that this is 134 degrees, but even though it's not written there, you know that this is also 134 degrees. So then how do you find K? Well, this must be a total of 180. So what you say is K, whatever it is, plus 134 must equal 180. Because this plus this must then be 180, so then you just solve it. So K plus 134 equals 180, and then we'll just subtract 134, and what we will get on the left is K, because this just disappears, K is going to be equal to 46 degrees. Circle that. So 46 degrees. And you can check it by putting 46 back in here. The 6 and the 4 would bring it up to 140, and the 140 plus the additional 40 is 180, so that is the correct answer. Let me take these down. We have a few more problems in this lesson. All right, here is problem number 4. We have this kind of rectangle here, but we have a rectangle where corner to corner it is sliced in half here, and we're trying to find angle J. So on the diagram, that is this angle measured from this segment here over to this one. So this is angle J. If you need to visualize it, you can kind of draw a little arc like that. That's angle J. Now, what do? We know that these corners here, these little squares, indicate 90-degree angles. So up here, what it means is 32 degrees plus whatever J happens to be must be equal to 90. So these are complementary angles. Remember, supplementary means they add to 180, but complementary means they add to 90, and these have to add to 90. So we say 32 plus whatever J is has to be 90 degrees. All right, so we'll rewrite it. 32 plus J is 90. Now, in order to get J by itself, we'll subtract 32 from the left, we'll subtract 32 from the right, and this will be 0, so we'll just have J by itself. What is 90 minus 32? That is 58 degrees. And you can check it by putting 58 back in here and adding it to 32. If you put 58, the 2 will make 60, and then 70, 80, 90, and so that makes sense. So the answer is 58 degrees for J, 58 degrees. All right, let's take a look at problem number 5. What is the measure of angle W, right? So this angle from this ray down here. Well, we know that this from this side of a line all the way to the other side must be 180. So these are supplementary angles. They add to 180. So 109, right, plus whatever W is has to be the same as 180. Right, but we want to get W by itself. So we subtract 109, and the only thing you'll have left is because this goes to 0, W, and then what is 180 minus 109? You get an answer of 71 degrees. So 71 degrees, check yourself. If you put 71 in here and add to 109, the 1 will make 110, and then 70 more will make 180, and you know the whole thing has to be 180 degrees. This is actually why we learn about complementary and supplementary angles, because it helps us solve problems, because we geometrically know it has to add to 180, and so we define those terms for that reason. All right, let's take a look at this problem. What is angle P? That is this angle right here between the rays. Now, it may be a little hard to see. You may have to turn your head sideways, but this is a line, and the angle that goes from this side all the way to the other side, again, has to be 180. So when you add this angle plus this angle, it must be 180. 143 plus whatever P is has to be 180. So 143, just spread it out so I have a little room. How do I get P by itself? I'm just going to subtract 143. Subtract 143. All I'll have left on the left is P because this goes to 0. And what is 180 minus 143? 37 degrees. So 37 degrees. You can check it by putting it back in here. The 7 going in here will make 150, and then 160, 70, 80 with 30 more, and that's the final answer. All right, here is number 7. Now this is where it starts to get a little more useful to write things as an equation, because you're trying to find angle Z, but this looks like a totally different situation than what we have covered before. We had lots of situations where we've had just a line and it's cut in one place, and we know they add to 180. So at first you look at this and you're not totally sure what to do until you realize that this must all be 180 degrees. So this angle plus Z, whatever it is, plus 73, all of them together must equal 180. So 68 plus whatever Z is plus 73 must all together add up to 180 degrees. All right. Now, when you add 68 and 73 together, you're going to get 141. Right? So how do we solve for Z? Just spread it out. And I can do what I want to both sides, so I'm going to subtract 141. 141 from the left, 141 from the right, so it disappears here. So Z is going to be equal to 180 minus 141, 39 degrees. So 39 degrees, and you can check yourself because we just figured out that these two together, when we add them together, comes out to 141. So if you put 39 in there and add it to this, it'll be the 9 will go in and make 150, and then 160, 70, 80, 180 when you add that 30 more, so it's 39 degrees. Let me take this one down. We have one more and call it a day. Okay, here's our very last problem. We're asked to find the measure of angle G. But it looks a little weird because on this side over here, we don't really have any other numbers. But what we have figured out is that there's a couple of different ways to tackle this, right? First of all, you notice that this is 90 degrees, right? So the whole thing is 90 degrees because of the square right here. So we could find G if we only knew what this angle was, but it's not really written here, but then we realize, wait a minute, it has an angle marking, and over here has another angle marking. So because this angle marking matches this one, we know that this angle is the same as this angle. In fact, it looks to be about the same, doesn't it? So actually, this 41 degrees is the same as this one down here, 41 degrees. And you know that because of the angle marking here, right? Now that you know that this is 141 degrees, you can write down that 41 degrees plus whatever g is has to equal what? 90, because this is a 90-degree angle. So we'll just solve that equation. How do we do it? Well, let's just subtract 41. This gives you 0, so all you have is g. 90 minus 41 comes out to be 49 degrees. 49 degrees. And double check yourself. You put 49 in here, and you add one more, that'll be 50. And then the 50 plus the 40 left over is the 90, and so you verified that it is 49 degrees. So this lesson was kind of, it's kind of an all-around measuring angle, calculating angle kind of lesson. It's kind of a hodgepodge of lots of different things. Basically, what we have is situations where we draw figures and I ask you to calculate the angle. And as I said at the beginning, you can solve all of these by addition and subtraction. If you look back through all of them, they're all solved by taking 180 minus or 90 minus, and you can do it that way, but I like to write the equations down, especially now that we've done it so much, so that you can practice writing equations down. Because this kind of thing, you'll be surprised when we get into classes down the road in physics where the problem is easy to solve, but the student can't get there because they don't know how to write an equation down. So we have to start with simple situations where, this plus this has to equal 90 and solve it. And this plus this has to equal 180 and solve it. Because later on, when we're in physics and we have a motion of a ball and a force, then we have to write an equation. This plus this has to equal this. And that skill of looking at a situation, a drawing that you sketch or that I give you, and writing down an equation is just as important as learning how to solve the equations. So even though these seem simple, I do want you to solve them by writing an equation. You're going to have to trust me that that skill will serve you well going down the road in your future studies. So practice these. We have more like this in part 2, so follow me on. We'll conquer it right now.